Hello my physics loving friends. I'm starting with current electricity lecture for CBSE and ISC boards. Firstly, I am to discuss Electro-Motive Force Emf. That is, in general, in plain language, it is terminal potential difference between positive and negative terminal of a battery in open circuit. But definition wise, it is defined as the maximum potential difference between the two electrodes of a given cell when no current is drawn from the cell or cell is in the open circuit. And then I is equal to Q upon T, and for if current is not steady, then of course instantaneous current would be discussed in the form of rate of change of charge with respect to time. Then definitely always charge could be calculated by area of IT graph. So that's why I have mentioned this point clearly. And then another important point I had to discuss is current is scalar quantity. Why? Because vector addition rule is not applied for adding up of two or more currents. Then drift velocity. What is drift velocity? And in this situation, constant acceleration. So finally, drift speed of or velocity could be derived mathematically by considering n number of free electrons per unit volume, that is n is number density. Notable point, students always miss this point. Mobility is defined as drift velocity per unit electric field. And then thereafter, the relation between current and drift velocity. Here, notable point, if we consider this diagram, and this is considerable part for deriving I is equal to NE AVD. Again is constant, that means V is directly proportional to I, which is Ohm's law. So then thereafter, but extension of this derivation was to prove the expression for resistivity. Equating these two, we obtain rho, which signify of course internal materials structure. Resistivity could also be defined as the resistance of unit cube. Unit cube. Very important factors which is very frequently asked in all the exams. Copper wire used as connecting wire. Why? Because copper has very high conductivity. That means very low resistivity. And why this is so? Because copper has very high number density of free electrons. Very high number density of. So hence low resistivity, therefore high conductivity. So this is the reason why copper has got very high conductivity. But silver is most conductive material. Why current is a scalar quantity? Because it is dot product of two vector quantity. And it is microscopic form of Ohm's law, which could be alternatively understood as vector form of Ohm's law. As temperature rises, resistance increases. That means resistance is directly proportional to temperature for any metallic conductor. Variation of resistance with temperature has got two important results. What do we mean by positive value of alpha? That means as temperature rises, resistance also increases. Negative alpha means as temperature increases, resistance decreases. And as we saw, variation of resistance with temperature, electrical resistivity or a specific resistance also changes with change in temperature. This is the discussion. So conclusion is of course common, that is, it is directly proportional to temperature. For copper, nichrome and semiconductor. Nichrome is the alloy of nickel, chromium and iron, whereas semiconductor necessarily includes silicon and germanium mainly. This is third color. After that, grouping of resistance. In series, current remains same, whereas in parallel, potential remains same. In series, potential varies. You could notice this V1 plus V2 plus V3 is equal to EMF E, whereas this I1 plus I2 plus I3 is equal to I. Why? Because in parallel, current is splitting. So these are two corresponding equations, basic equations for getting equivalent resistance in series and in parallel respectively. Here comes, we have equation of discharge. Why do we say equation of discharge? Because as and when cell is connected in closed circuit, it start getting discharged. So that's why V is reduced value of potential drop across the cell, and this is lost volt, IR. This is internal resistance of the cell. EMF is source of electric current, whereas it is after effect. That's why it is cause, it is byproduct. When any cell is being charged, that means it has to regain all the electrical energy which it had lost during discharge. But this could be only happening when the cell is rechargeable. And suppose this is charging source and this is a rechargeable cell. That means this is getting charged and this charging source is getting discharged. Identical cell and unidentical cells. Then thereafter identical cells grouping could be further categorized into series, parallel, mixed grouping. Parallel में what we saw, EMF is same, so that's why this will be taken E only, because in parallel potential difference remains same. I total current in mixed grouping is NE upon R plus NE. Why NE? Because n number of cells in this first row, and then thereafter all these rows are identical. All these rows are identical. So in parallel potential being same, so any m times it will remain any only. And then in denominator we should have total resistance of the circuit, so this is external resistance and this is total internal resistance. How? Because this is small n into small r, then it is m number of horizontal rows, so that's why NR, all these are parallel branches, so NR by m times, so hence it is NR by m. condition for maximum current or maximum power. It should be total external resistance is equal to total internal resistance for any electrical circuits. It is condition for maximum power. So here also, grouping of unidentical cells in parallel. Suppose these two cells are connected in parallel. Remember, these two cells are unidentical, different E, different internal resistances. Obviously, both the cells will be sending different currents as well, I1 and I2. Suppose these two cells could be replaced by single cell, that is E equivalent, whose internal resistances are equivalent. Then these two values has to be determined. In parallel, potential difference remains same. That's why V1 is equal to V2 is equal to V. And this is equation of discharge is used. With the help of these two facts, I have considered these two equations and corresponding values of I1 and I2 is obtained, then which will be substituted in the equation I is equal to I1 plus I2, equivalent EMF and equivalent internal resistance. So I would welcome all of your doubts in comment box. Those numericals I am to take up in next video. So try to understand this theory, otherwise I am to explain while solving numericals. First law is junction rule, that is total incoming current is equal to total outgoing current for any junction. And second is total potential across any closed loop is 0, which is discussed in this paragraph. If you won't be able to understand how to apply, then I'll be covering up in next video for solving purpose. Meter bridge is practical form of Wheatstonebridge. This is resistance box. This is unknown resistance which has to be found, and this is the null point. After obtaining null point, now AJ part is P, resistance P, and JB part is Q. Point to note that L is balancing length. Obviously for Q part it is 100 minus L. Why? Because this is 100 centimeter uniform resistance wire. That's why it is meter bridge. And why it is named slide wire? Because for obtaining null point, jockey has to be slided. Again, same thing from Wheatstonebridge only. Wheatstonebridge principle is applied. Why? Because this meter bridge is also practical form of Wheatstonebridge. Unknown resistance. Potentiometer. Why we prefer so complicated instrument for measuring potential difference? Because potentiometer is based on null deflection method, zero deflection method, whereas voltmeter, ideal voltmeter will be giving the ideal reading of potential difference if and only if it will have infinite resistance, which is practically not possible. Working principle. K is potential gradient. Dimension volt per meter. Simplest diagram. When galvanometer shows no deflection, then only through the circuit mentioned some analysis could be done. Otherwise, no analysis is possible. Another very important, driving cell or auxiliary cell. This is driving cell. This EMF should be always greater than this lower cell. Greater than or equal. K should remain always same and constant for any given potentiometer. Now we can go further. So here also, here I have mentioned value of K for any smaller part of the same potentiometer or full part remains the same. As balancing condition, at balancing condition G shows no deflection, then EMF of the lower cell, EMF of the lower cell should be equal to this potential difference VAJ. That's what I have. These two one in great detail because these are different theoretical topics. Calculation of K. Comparison of EMFs of two given cell. In the given circuit, point to note that when this junction 1 is connected to junction 3, that means only E1 has to be considered. L1 is the balancing length obtained. That means J1 is the null point. But when this is disconnected, now 2 and 3 junctions are now connected. then that means cell E2 is considered. Then for this E2 cell, now J2 is the null point obtained at L2 length. So in both the situation, these two different equations obtained after dividing, we obtain. This is important. Then thereafter, internal resistance of the given cell. What do we notice here? In lower part, this cell internal resistance has to be found. This is our main aim in this topic. But notable point is, initially this key is only pressed, this is unpressed, so this is not considerable initially. So in that case, L1 is the balancing length obtained at null point J1. So that's why E dash is KL1 for this E dash. And this resistance box is signifying internal resistance of the cell. But after that, when this switch K1 is also pressed, then definitely there will be some reduced value V, not E dash. There will be some reduced value. So that's why, because of this reduced value, so balancing length will be also reduced, and balancing length is reduced, obviously J2 will be shifted leftward, because V is directly proportional to L. Potential drop across the potentiometer wire is directly proportional to the length. So hence this equation is obtained, and already we have got this. After dividing these two equations, we get this, and then thereafter, by considering this earlier, we have read this formula. After substituting, we obtain. So hence we are able to finish this whole part. Thanks for viewing and enjoying, all my physics loving friends. So you have had patience, but remember, do comment. आप ज़रूर कमेंट करें in my comment box, mail करें. These are my 2 email IDs. आप यहाँ से डायरेक्टली मेरे चैनल पे भी वापस आ सकते हैं. This is my WhatsApp number. Bye. See you in next video. Thanks. a lot. Please like my video if you like it, and please subscribe my channel Sufal Physics Forum also.